Hey, Caitlin.
Hi,
How are you, sweetheart?
I'm good. How are you?
Good. My family's cooking in the background, so hopefully that won't be too distracting.
Okay.
Um, did you want to start with Friday's assignment, the online activity, or do you want to do some problems out of the book?
Um, Friday's assignment, if that's okay. That one in the synthetic division from yesterday. Those are the two.
Okay. Okay. So I'm sorry I turned down my volume a little bit too much to hear the first part. Did you want to do the in-class assignment from Friday, or just some of the book work?
Just the in-class assignment. I think that's mostly what I was having problems with. But
Okay. All right. Let me open that. Hold on just one second. And then I'm going to try and share it on the screen with you. We'll see how that works. Prayers appreciated. Because I don't think it's weird. I finished the two from yesterday, but I actually didn't finish the one on Friday. So that actually could be a good thing because I'll finish it with you.
all right, cool.
All right. Now let me try to share it with you.
Okay.
Oh, hey, thank you. Let's see. Lord, please let it work. Okay, do you see it?
Yes, I see it.
Okay, great. And I'm kind of starting from scratch. The difficulty is that I don't know how let me see, let me try something else too. It's not letting me. It's either not printing or choosing not to print. Okay. Now for the first one, did you do okay on it, or
Yes.
should I do that one?
No, I did okay with that one. It's 1 through 3. Well, okay, I struggled with 3, but I think we figured that one out in class. Um, it's basically all the others, I think. I got past a few of them and still didn't get the right answers, so I figured I'd just talk to you about it. So,
Okay, and now I'm gonna try something else because I'm struggling with having.
okay, there's a. Oh, it's the first one. Okay.
Oh, it did come up.
Hmm.
Like I say, I'm struggling with places to be able to write problems
Oh,
down.
yeah.
What are you seeing on my screen? Are you seeing me open all these files?
Um, yes.
Or not? Or you are, so you are. Okay.
Yes.
I just was curious. Kind of boring. Sorry.
That's all right.
I have the other ones too, so if we get to those, the other activities, and I actually have those completed,
Oh, okay, cool.
I'm gonna write down. I'm gonna start with 3. Does that sound good?
Sure, yes.
I'm just writing the problems so that I can put it on the other screen.
Okay.
These, I will tell you, the tricky thing about all of these are taking them one step at a time and applying rules as you go.
Mm-hmm.
That's the most, and it can be, honestly, a little, it can be tricky, for sure.
Yeah. When I was watching the video, I don't know, it didn't seem that hard. It's just kind of, I don't know, simplifying and
Yes.
trying to go back over the notes and find out which part.
This one had a lot of pieces and parts, moving parts to it.
Yeah, it did, surprisingly. It looks small, but no.
Is it small?
I mean, no, it doesn't. No, not that. Sorry. I mean, it doesn't. Just looking at the problem, it seems like it would simplify not too hard, but
Not too difficultly.
yeah.
This one definitely had some moving parts to it. So, all right. So the very top part, because obviously we're dealing with groupings. So the very top part, I probably wrote too big, unfortunately. The very top part, we'll go ahead and simplify that all the way across. And you would have 16, because you've got 8 times 2 is 16. And then when you're doing the x's, there's an understood 1 right there. Okay? So it's 1 plus 3. So you would have x plus 3, which equals 4. And then y to the 3rd times y to the 4th, which would give you y to the 7th. Okay. That's the top part, okay?
Mm-hmm.
Can you hear me okay?
Yes, I am. Sorry.
Can y'all try to keep it down just a little bit? Sorry, I would have started this upstairs if I would have known. Okay. Now, on the bottom part, the very first term, you've got -7 x cubed y inside parentheses, and then outside the parentheses, that's all squared. So you have to square each individual term. That's the very first thing you've got to do. Okay. So -7 squared is 49.
And then and then you'd multiply.
And then, right? Yes, ma'am. Good job. So that would be x to the 6th, okay, and y to the 2nd.
All right, cool.
Okay?
Yes.
Minus x to the 6th, y to the 2nd. Okay?
Okay. All
right. Now, I'm going to erase the top part, if that's okay with you, and then go back up there. Is that okay?
Yes, that's good.
Okay, I don't want to mess you up by taking something away, but I think I wrote too big.
That's all right.
Okay, so my top part's going to stay exactly the same. Okay. Right at this point, because I haven't really done anything with it yet.
Mm-hmm. Okay.
But the bottom part, I'm going to go back to the bottom, and I'm going to add a 1 right here for it to make a little more sense when I do this, okay?
Okay.
See this part and this part. See, they both say x to the 6th, y squared. And do you remember way back even in pre-algebra where we combined like terms?
Yes.
So you could combine x's, you could combine y's, you could combine x squareds or y to the 4th and stuff like that. Well, this whole thing on each of these sides, that's really technically one term.
Okay. Would it
okay? They're considered one term.
Okay.
Now, if they were being multiplied, we would specifically say, okay, we would add the exponents. But in this particular case, we've got this 49x to the 6th y squared as one complete term, and this 1x to the 6th y squared as one complete term. So we're subtracting technically 49 of them. We're actually subtracting one of them from 49 of them, which leaves us 48x to the 6th y squared.
Okay. That. All right. I think that makes sense. Cool.
Okay, so that does make sense to you?
Yes, I think so.
So now we will simplify, and 16 goes into 48 3 times. So we have 1 on the top and 3 on the bottom. And now this crazy looking number up here was supposed to be a 4. So that's x to the 4th minus 6, which would give you x to the negative 2, or basically just write x squared on the bottom, because if it's negative, it goes on the bottom of the denominator, and if it's positive, it goes on the top. So my 7 minus 2 would give me y to the 5th. So my final answer is y to the 5th, 3x squared.
Okay. Okay. I think that's where I messed up, is the last part. And it was, I put the x and y both on the top or both on the bottom or something.
Something to that nature. Yes. Yeah. Determining whether, so like, I'm just going to write this 4 minus 6, which is what our exponents were. That gives me a negative 2. So that negative tells me it's going to be down here on the bottom.
Okay. All right.
And then the 7 minus 2 equals 5. Since that's positive, that tells me it's going to be on the top.
Okay.
So then I would go back over to my happy little thing if I can find it. I'm in the middle. And I would take this.
Mm-hmm. Oh, and you'd put the whole problem in that. Okay.
And then I find my answer.
I was messing that up too.
And I think here it is, right?
Yes. Well, yes, y to the 5th over.
Oops, didn't mean to click there. I want it. It keeps going there. Oh, there we go. So I would put that one there.
All right, cool. That makes sense.
Does that make sense?
Yes, it does.
All right. Shall we move to the next one?
Yes, ma'am.
Oh, oops, I picked the wrong one, didn't I?
Oh, maybe. That's fine.
That makes this a little more tedious when you don't pick the right one, doesn't it?
Tiny bit.
That's the right one.
Yes.
All right. So at number 4 then?
Mm-hmm.
You want to move to that one?
Yes, if that's okay.
Oh, yeah, that's fine. Absolutely. I'm writing it down so I can, when I go back over there, I'll know which one it is. I wonder if I can, I'm going to try something. Don't know if it'll work, but I'm going to try.
Okay.
Is my screen moving every time I move to something else?
Yes, it is. I think so.
Okay. Praying this works. I don't know if it will or not. So I'm going to have to go back and finish writing it. X to the 10th, y to the 16th. Okay. I'm going to try and write smaller this time.
Yeah.
-9, x to the 4th, y to the 7th, all squared over -27 x to the 10th, y to the 16th. So the first thing I'm going to do is work with the top. So I've got -9 squared, which is going to be a positive 81, and then x. So those two are, this is multiplied by that. So that gives me x to the 8th, and then y to the 14th. Does that make sense so far?
Yes. I missed
Okay.
I missed the you have to square the 9 too. I think it just
Yeah, you know what? That happens to me a lot too, and that's where that just, it's all a detail thing, you know, of just paying attention to that. That seems to be one of the most common mistakes, I think. Like when I'm quickly going through something, that seems to be the most common, you know, for where I will mess up, you know, as well.
Yeah.
And now on this one, believe it or not, -27 will actually go into both 27 and 81.
Okay.
So
right, because
that would cancel to be 1, and this is, or actually this would be -1, and then this would be 3.
okay. Yeah, I think that's where I messed up. The whole problem is.
Okay. So, and then 8 minus 10 would give me a -2. So my x would stay on the bottom because it's negative. And then 14 minus 16.
And -2 again, so.
Yeah.
Right.
So, and when I go back over, I'm not really sure, you know, what answers are going to be my options.
Mm-hmm.
But with regard to a fraction,
Yeah.
the negative can be at the top or the bottom because technically it's a division problem.
Oh.
And so it wouldn't matter whether it's at the top or the bottom. Does that make sense?
Yeah, I think so.
Because a fraction, you know, a negative divided by a positive gives you a negative answer. So it wouldn't matter which one, where you labeled it. And sometimes it'll actually be labeled just on the outside of the fraction itself.
Okay.
So now I'm looking for the right answer. And they actually had it on the top. I'm glad I stated it before I got here. So
Yeah.
this right here, these two technically are the exact same thing. You could have a negative on the bottom or a negative on the top, or it can be actually written outside in front of the fraction overall. Does that make sense?
I think so, yeah.
Okay, good. All right, so that on the last.
Okay.
Oops. Thank you, Brooke. That's the one we just did, right?
Yes.
So I would copy it to there.
Okay.
Okay?
Yes, that works. Awesome.
All right. All right. So you want me to do a few more?
Sure. What was it? I think. Yeah, I have to find them again. Number 10, maybe? Is that?
Number 10.
Yeah.
Okay.
I don't have written down which ones I was.
Now,
messing up.
I do want to draw your attention just for a brief second back to 5 is because the whole thing is squared, the whole fraction itself. So you would have to actually square 60 and 5 on the top and the bottom.
Okay.
Okay?
Actually, could we go over that one too? Because just to make sure.
Okay. I'll do that one and then we'll do 10 next.
Okay.
Is there too much commotion in the background? Can you hear me okay?
Oh, I can hear you fine. I can't hear almost anything actually from the background, so.
Oh, praise the Lord. Okay. Good. All right, let me go back here. I'm going to erase the previous one. Did you get all that written down
Yes.
as we were going?
Mm-hmm.
Okay, good. Did you all lose power or anything?
No, actually, we had power the whole time. I think my
Yeah.
who was like a mile away. She did lose power, but we didn't. Got lucky.
Oh, a mile away?
Yeah.
Wow. Yeah, it's weird. One of my friends from Indiana was checking on us, and she told me that 2 people were killed by trees falling in on their houses. One of them was in Buckhead.
Oh, wow. Oh.
I know. I hadn't even heard it. I had to have somebody from Indiana
Wow.
call. Crazy.
Yeah. Oof. That's scary.
She said, I guess one of them was on the Weather Channel even.
Oh. Mm.
Was filmed from the Weather Channel. Crazy.
Oh, wow. They actually filmed the tree falling?
Well, the aftermath, I think, of the house. You know what I'm saying?
Yeah. I was like, that would be pretty much scary coincidence. They happened to pull out a video camera as the tree is falling on the house.
No doubt that would be kind of crazy. So I'm going to square each individual term. So 3,600 x, and then I would multiply that. So x to the 20th, and then y to the 14th. All over. And then 25, that's because that's 5 squared. X to the 8th, because once again, when a power is raised to another power, you're multiplying. Y to the 6th. And so then I would divide. So that's going to give me 144 on the top, and then a 1 on the bottom, which I'm not going to write. And then I have my x's. That would be 20 minus 8, which is going to give me a positive 12. So that's going to go on the top. And then 14 minus 6 is also going to be positive 8. So I really, technically, my final answer is all of that would have been over 1, so I could have just written that.
Okay.
Okay?
Okay.
All right. Now we'll go back over here and see if I can find it.
It's on the fourth side. Yes.
There we go. All right. Cool. Okay, so we'll, in number 10 was the next one. All right, let me write it down. And x to the 6th. 11.
It's mostly division problems, but I think that's the only other one that I somewhere messed up on.
Oh, okay. All right.
Since we've already done a few division ones, that's.
Yeah, this one is going to be one where there's going to be some, definitely some funky details to it. So it's a good one to hit.
Yeah.
Really good one to pick. Excellent question. All right. Get this erased. Okay. 10 x to the 6th, y to the 4th, all squared. Hope I have room with my big, I'm writing with my fingertips, so I forgot to start it on, I have a Chromebook that they gave me, which was really precious, but I was already working on my laptop. But the Chromebook that they got for me to do this has a wonderful stylus, which helps a little bit. It's little easier to work with.
Yeah.
I don't think it'll work on this. I may try just to see if it does. Okay, so first thing that I'm going to do is simplify
Parentheses.
this right here. So I've got to do 10 squared, which is 100, and then 6 times 2, which is x to the 12th, and then 4 times 2, which is y to the 8th.
Okay.
Okay?
Yes.
And then over here, using order of operations, I would have to multiply this part together. Okay?
Okay.
So I've got 11 times 4, which is 44, because I have to multiply before I add. That's why I said order of operations. And then x to the 5th times x to the 7th is going to give me x to the 12th. Agreed?
Yes, agreed.
Because when you're multiplying bases and exponents, the base is the same, you add the exponents. And then this y is an understood 1. So y to the 1st times y to the 7th would be, I would add my exponents 1 and 7, which is going to give me y to the 8th.
Okay.
Okay, so now my final part is to combine like terms. And the x to the 12th, y to the 8th, x to the 12th, y to the 8th, that is a like term. The only way I could add these is if those two terms were like. Does that make sense?
Yes.
Okay.
All right.
So that's going to be 144 x to the 12th, y to the 8th is my final answer.
All right, cool. I can see where I messed up on that one too. So.
Yeah, these were definitely detailed, and this is going to serve you very well for pre-calc because they a lot of attention to detail on that. So we got the same answer on 10 that we did 5.
Oh, yeah.
Right? Wasn't it the same?
Yes, it was.
Okay.
That's a little bit scary too.
Huh?
That's a little bit scary too, because it feels like so many answers.
How different they are, and yet they turned out the same.
Mm-hmm.
You know?
Yeah. That's all right.
Would you want to, and I will do as many as you want to, or we can move on. I don't care.
Okay.
You're the only one here, so it's a private tutor session.
Yay. I think that's good. We covered the division and that one, so I think that's good.
Okay. Well, I will definitely finish this, and then I'll just share my whole assignment with you so that you can check your answers. How's that?
All right, that sounds good. Yay. And could we look at the synthetic division? Sorry.
Absolutely. Do you want to look at the class activity, or you just want to do some synthetic division problems?
The ones on the slides, if that's
Okay. I already have those done,
okay.
but I can kind of undo them if you want me to.
If you just maybe, I don't know, tell me how you got through the problem, because mostly, at the very end it says equals, let's see, x minus 3 plus 6 over, what is it, x minus 1?
Yes, ma'am.
I think I did something wrong in working this. I asked a friend about it, actually, and she had a lot more numbers on the slide than I did. So, I don't know where they got x minus 3, then plus the,
Okay.
so it just kind of.
All right. Well, let's talk about the fun part about actually doing this slide is I think I can manipulate my numbers a little bit for you.
Okay.
To tell you where I got them, which that'll be good, I think.
Yeah. Good.
Oh, that's a completed example. Okay. So this is my very first one that I did. Okay. So here, where I got this -1, you see me kind of moving it around?
Yes, and I can see your arrow too, the little hand thing too.
Oh, you can?
Yes.
Okay, good. I don't know what you can see, so that helps me to know. All right, where I get the -1, that's determined by this denominator here.
Oh, it is. Okay.
And you kind of take the opposite of whatever it is. So like this says x plus 1. So I know in my division problem over here, that's going to be x minus 1. And I'll explain a little bit more about that. A lot of that has to do with if I were to really solve, set that denominator equal to 0. If I did x plus 1 equals 0, it's telling me that x would equal -1. Does that make sense to you?
Okay. Yeah, I think so. Yeah.
All right, let me go over here and erase all this and then write that out. Because that's what determines what your quote unquote substitution or division, what you're going to be dividing by.
Yeah.
Okay. And actually, I think what I might do, oops. Is I might write this whole problem down and then we'll go, and I might rework it over there. And then we'll come back to this. All over x minus 1. No, plus 1, right? If I were to set that denominator equal to 0 and solve, I would get a -1.
Okay.
Right? So that's where I get what I'm going to divide by.
Okay.
Oops. So that's what goes over in this little box over here.
Okay.
Okay?
Yes.
All right. And then what the numbers that go all the way across here, this.
Yeah.
What is the coefficient of x cubed?
Just 1.
So that goes there.
Yeah.
Now what's the coefficient of -x squared?
-1.
So that's why this is here. This one right here.
Yeah.
And what's the coefficient of this one?
4.
So that's why the 4 is there. And then the last and final constant is
-5.
-5. Good job. So that's how you set up the original problem.
All right.
Do you want me to work it out over here?
I think.
Or
Yeah.
keep explaining from the slide? Your choice.
I think maybe just keep explaining from the slide, because somewhere in the okay, for this -1 in the separate box, the first one, where you know set x equal to 0, and it gets -1. Sorry, I'm confusing. Would you multiply that by the first coefficient to get? No, you wouldn't, because that would still be -1 if you did that.
No, the very first thing that you do is just bring this one straight down. There's no multiplying or anything on the first one. You just bring it down.
Okay.
So whatever this leading coefficient is going to be right here, it comes down.
Okay.
And now that it's down, you multiply this one times this -1, and then you put it right here.
Okay. See, that's okay. Makes sense.
And then you would take -1 plus -1, and you get -2.
Okay.
And then I take my -2 and multiply by -1, and I get a +2, which I put right here.
Okay.
And then I add 4 plus 2 equals 6.
9 times -1.
And then I multiply my 6 times my -1, and I get -6 over here.
Okay. Thanks.
And then I add -5, -6, and I get -11.
Okay.
Now, to transfer my equals into my box, I take each one of these numbers that I got in my synthetic division or synthetic substitution, as they called it in the book, and I believe also in the video, and I see my coefficient up here is a 3. Not my coefficient, I apologize. My exponent is a 3.
Yes.
I'm going to go down 1. So my very first exponent in my answer is going to be a squared.
Okay.
So I apply this coefficient, which is +1. So I have x, which I don't have to write, because the coefficient on a variable, when there isn't one, is an understood one. So I've got 1x squared minus 2, and then I just keep going down the line and attaching the next lowest degreed term to whatever my answer is here. So my next lowest degree term is x to the first, so it's -2x. Then this number 6 is going to be my constant, so +6, and then this is my remainder, and it will go, that remainder will go over my divisor.
Okay. All right. I guess that makes sense. I'm gonna definitely.
All right, well, let's go. And then what you do is you go all the way down to your answer sheet. And I just typed in, I was able to use the superscript on my first answer, but that last part, so I just put in x squared minus 2x plus 6 minus 11 over x plus 1. I just typed it.
Yeah.
You don't have to go back and copy all that stuff again.
Okay.
All right, let's try this one, number 2.
Okay.
All right. So do you understand where I get a -2?
Yes.
For my divisor?
Setting the.
It's the opposite, or basically if you set x plus 2 equal to 0, I would get a -2, right?
Yes. Nice.
Okay. Now this one's a little trickier because I've got a 1 for my leading coefficient on my x to the 4th term, but I'm actually missing a term, which is x to the 3rd. So I can put my 1 here for my x to the 4th, but in order to be in proper form, I have to put a 0 in for my x to the 3rd. That's called a filler.
Okay.
So I have to put a filler in because every single position has to be represented by something. So I put a 0 in for my x to the 3rd. And now the coefficient on x squared is what?
On x squared is -1.
Yes, ma'am. Good job. And then once again, I'm missing one other term, which is just the single x term. So that's why I've placed this filler or this placeholder I think she called it a placeholder in the video. Is that correct?
I think so. Something like that.
Okay. So the 0 is the placeholder for my x. And then my constant is my 9.
Okay.
Okay, so I go back over here, and my 1 just drops straight down.
Okay.
And then that's where my first multiplication comes in. So I'm going to multiply 1 times -2, and I get -2. And so that goes here. 0 plus -2 is -2.
Okay.
And now -2 times -2 is +4.
Okay.
-1 plus a +4 is a +3. And +3 times -2 is -6. And 0 plus a -6 is -6. And then a -6 times a -2 is +12. And +9 plus +12 gives me a +21.
Okay.
So that was the division part. And now, once again, our highest degree term in the original problem is 4. So I'm going to start in my answer with x to the 3rd. And I applied this coefficient, which is 1, to x to the 3rd. And since 1 is always understood, I don't necessarily have to write it there. And then I go to the next number in line and I apply that to the next highest degree term, which would give me a -2x squared. And then I go to my next term in my answer, which is a 3, and I apply it to my next highest degree term in my answer, which would be 3x. Does that make sense?
Yes. Yeah.
Where I'm getting those? And then the next place in line would be your constant, which is 6. So I move my 6 would be my constant in my problem. And then this final number here is 21. So my remainder goes over my original denominator or divisor in the problem.
Okay. Why would it only be the last remainder to be over x plus 2? Yeah.
Okay, so why is it the last number?
Yes.
Okay.
I'll go over them at least.
Okay. Because each of these kind of have their place in the answer. If you start if you start with x to the 3rd, which is where we have to start because the highest degree in the original problem that we're dividing is 4.
Mm-hmm.
So your answer starts with the very next highest degree. Does that make sense?
Okay, yeah.
So you have x to the 3rd, and then so your first one applies to that. Your second one applies to x to the 2nd.
Okay, yeah.
And then your third one applies to the next highest degree, which is x all by itself.
Okay.
And then your last one is your constant. So anything after your constant would be what we would call the remainder.
Okay.
So it would be like if you had a regular division problem, just like a regular plain old division problem like we did back in 3rd grade.
Yeah.
It'd be like if you have everything in your place values prior to the decimal point,
Mm-hmm.
anything that you would have left over in a long division problem, that part would go over the divisor.
Okay.
And that's what this is. This is a remainder of a polynomial division problem.
Okay. There we go.
That's just, it's called the remainder. And
All right.
you're really going to understand that a little bit more. That'll become clear when we do the remainder theorem and the factor theorem, excuse me.
Okay.
But this is just the remainder. Just like in a long division problem, how we used to have remainders before we did our decimal points and all of that.
Yeah. All right. I didn't connect those, so that's okay. Makes sense.
Okay. All right. So that makes a good connection for you and helps kind of clarify why that part goes over.
Yeah.
Okay, cool. All right, good.
Yeah.
All right, do you want me to do a few more?
I think I can work out some of the rest. Are there any that are kind of different from the others or more difficult or something?
Let me take a real quick look. I mean, number 3 is different only because there's actually a coefficient other than 1 on the leading term, so I could walk through that one with you if you want.
Yeah.
Just because the leading coefficient is different. You know how so far they've all been 1?
Yeah.
On this particular one, the leading coefficient on the first term is a 2.
Yeah.
So I write down my 2. And then the next coefficient on this term is a 1.
Okay.
This one's a -8. And the final one's a 5.
Yeah.
So I write all those down. And just like all of the other ones, I bring down the 2.
Okay.
And then 2 times -3 is -6. So it goes right here. Can you see my cursor okay?
Yes, I do.
Okay. So 1 plus -6 is -5. And then -5 times -3 is a +15. And -8 plus a +15 gives me a +7. And then 7 times -3 gives me a -21. And then 5 plus a -21 is -16.
Okay. Yeah.
So on this particular one, the highest degree is a 3. So my answer will start with an x squared.
Okay.
But I actually take this coefficient and apply it to the x squared. So it's 2x squared. And then I take my -5 and I apply it to the next highest degreed variable, which would be x. So it's -5x. And then 7 in this problem is going to be my constant. So anything after the constant or this final answer right here, the -16, is going to be my remainder. And it goes over my x plus 3.
Okay. All right. I think that makes sense now.
Okay, good.
More.
Good. I'm glad. Now, what about the other part? Were you okay on predicting the end behavior of a polynomial? Or would you like me to bring that one up? And I will share my synthetic division slides with you, and I will share my exponent activity with you too, so you got the answers.
Okay. I think the other one, that was okay.
That was okay? I'll share it with you just in case.
All right. Thank you.
I'll share mine with you, and then that way you'll have all 3.
Oh, cool. That'd be awesome.
Okay. And do you need see, I posted the answers to the other work, the book work. I posted those on Google Classroom. Were you able to pull those up okay?
Yes. I haven't looked over that much, but yes.
Okay. All
Not at
right.
all.
Well, because I think I posted it. I believe I posted it yesterday. I can't remember now.
Yeah.
All these stay-at-home days are running together.
Yeah. Homework. Yeah. Same for me.
But I'll make sure you have the answers to everything, and you can always email me if you have a question or if you get stuck on one of these later or anything like that. Please email me. I appreciated you letting me know where you were.
Okay. Well, thank you so much for explaining that and sharing the answers. But
Oh, no problem. And as soon as I get off Math Lab, I'll do that. I'll share it with you.
all right.
Okay?
Yes.
I don't know. Actually, let me see if I can.
Ooh.
I think I might have shared it with somebody so they could edit. I was like, I need to make sure.
Oh. Yeah.
There you go. That should be coming your way.
Okay. And there it is. Yay.
Okay. And I think if I share this with you, even when I make changes to it, you'll be able to see it. So I may go ahead. Isn't that true?
Yes, it is.
So I'll go ahead and share it, and you'll be able to see it as I continue to work on it.
Okay. Awesome.
All right?
Okay. Thank you.
Oh, no problem. Happy to help. Thank you for coming to Math Lab. There's bonus points for it.
Oh.
So, all right. You have a great day.
You too. Thank you.
You're welcome.
See, I don't actually know how to turn it off. There it is.
That darn time.